All right. Stockpiling. It's critical to everybody's operation, isn't it? So we're going to talk about how to minimize and improve performance. So if we took all of our materials and we could separate them into individual sizes, we wouldn't have to worry about segregation, right? Because it wouldn't come apart. But yet, when we're talking about our mixed designs that Trenton just went over, all those different particle sizes are in there. And the bigger the particle size distribution you have, the greater chance you have for segregation, for it to come apart. And these are all the opportunities we have for segregation. Starts with the drilling and the blasting, and then loading from the shot, the muck pile. And then as we go to the primary pile, conveyor belts, transfer points, stockpiles, loading and transporting and dumping and spreading. Every one of those steps can create opportunities for segregation. So let's start here with drilling. So you can see over here we've already got a shot laid off. And here we're drilling. Here they've got one set up to shoot. So what can we control? It starts at the muck pile, like I said. You can see in this photo here that you've got the fine areas and the coarse areas. So if my loader operator's not paying attention and he loads from just one side and brings it up to the primary, and then the next time he goes into the other side and loads all fine stuff, we're done. It's already segregated right from here, from step one, from drilling and blasting and loading to the primary. We also have different, when we do a shot, you can see that you've got some of the bigger boulders here. And then there's your shot back there. And that's rock breaker rock over there where we break it up to the right sizes to where it'll fit in the primary crusher. Well, if I'm loading shot rock, and then the next haul truck comes down and they load them up with the rock breaker rock, what's that going to do? We're done again. It's going to segregate terrible in the plant. And there's your primary. That's where it goes from the shot to the muck pile to the primary. There's your next step. So consistent feed to that primary is critical. Okay, so we go through the primary. Again, if we're not consistent there, when it goes to the secondary and the tertiary where our final products are made, there's no way it's going to be consistent. And just think, if we can't be consistent in what we're doing at the quarry, how are you guys going to do that? That's one of our rock quarries. But transfer points and conveyors create segregation. But yet we need to move material from one point to the other, right? You can't just take them out. But look at all those opportunities. And every one's an opportunity to create segregation. So as it's going over the idlers, it's bouncing, right? So what happens when you've got a bunch of different size aggregates on that conveyor belt and it's bouncing? That's what happens. All your fines are going to migrate down to the bottom and your coarse is going to stay up on the top. So we know this. We know this happens. It's part of the mechanics of bringing rock from one part of the plant to the other. It's going to occur. So we have to take steps to continually try and put it back together again. So as it's coming off the head pulley here, another opportunity on a day like today or yesterday where you've got high winds, as that aggregate comes off the head pulley, the wind's going to catch that fine aggregate and drive it to the back of the stockpile. And the coarse stuff being heavier is going to come to the front. Even if there's no wind, just the different weight of the product and going over the conveyor belt like it does, it's going to create segregation in there. And again, we know this is going to take place, so it throws up a flag. What are you going to do about it? And like Trenton was saying, we want to try and eliminate huge drops of that rock because that's another opportunity for it to come apart. So we want to keep our stacker as low as we can, The other thing we want to do, and this could apply to you guys if you have drive-over hoppers to stock your material at your plants too. Look at how this is segregated here. Because we're dumping it over the side of the pile, the more opportunity you give that material to roll, the more it's going to come apart. It just has to do with the gravity and the different size particles that it's coming through. So that's what a stockpile looks like. And again, just like the conveyor belts, it's going to happen. We know it's going to happen. We can't fix that. We can minimize it, but we can't completely fix it. So if you know it's going to be like that, then you make a plan. How do we get it back together again? This is a Thor stacker, state-of-the-art telescopic conveyor. And we use it to minimize segregation. This was down at one of our plants in North Carolina. And as you can see, it was a relatively new plant at that time. And those guys weren't experienced with using a conveying or telescopic stacker. So what they were doing was they were keeping the stacker out in the pile, in the front of the pile, and they were actually creating segregation with the stacker. And what you want to do is go out a little bit and then work your way back in to prevent segregation. And what they were doing was they were staying out ahead of the stockpile, creating segregation. So again, you can have great equipment out there. Again, that's state-of-the-art conveyor there. But if you don't use it the right way, you create segregation. So let's talk about building and maintaining stockpiles. So what we're doing here is you can see that the fall is minimized there, and the stockpiles, the dumps are pretty close together, and that's going to help minimize segregation. A couple things with this slide here. Number one, when you dump it over the front of the pile, it's just like that Thor stacker. It's all flowing right over the front. The other thing with this is that's pretty dangerous to do, right? Because all that weight's going up in the air at the edge of that stockpile. And you can see that that's an open graded material, not a dense graded material. He could take a nice ride down that hill. You'd only do it one time. So this is how we want to build our stockpiles. Just like with that, the first slide that we had there, you want to build them small and tight, close together, so that rock doesn't have the opportunity to roll and separate. We've got to move those small dumps, and there's a way to do that by layering. And you can see that if I'm doing it off of a stacker or from truck dumps, I want to make sure that I'm not running the material off the end of that pile again, creating segregation. And I want to build it in layers, not great big layers, but layers where it won't come apart on me. This is like that stacker. You're throwing it off the end of the pile, what are you doing? You're creating segregation, right? You're giving that rock a ride. The coarse stuff's heavier, it's going to fly to the outside and roll down the hill, and the fines are going to stay closer in. So good intentions to mix that stuff up, right? Push your piles, keep them going. But there's a right way and a wrong way to do that. And we got to make sure our loader operators are doing it the right way. So we want to make sure we're pushing off our piles. We've got to do that to, again, create space so we can build big stockpiles, which we have at the quarries. But we want to do it the right way. See how he's got his bucket low and he's pushing a big load over? That's the right way to do it right there. So what we want to do is take our stockpile and separate it into sections, right? Because we know from looking at that slide before that when we build a stockpile, it comes apart, right? The coarse stuff goes to the outside, then you have your center cone fines. So what we want to do when we move that is to make sure that we work the face of that pile. So I want to visually break that up into sections, right? And then I want to make sure that I'm not going into that same spot. I want to work the whole face of that pile. So I'm building a mini pile now. I've taken the segregation that we get from having a conical pile, and I'm taking that out. I'm remixing it because I've got to move it from underneath the stacker anyway. So what I want to do, again, knowing that it's going to segregate in the stockpile, I'm going to put it back together again. See how he's working the face there? And then push it over the side. And again, not throw it over the side, but push it over the side. Because he could build that mini pile and then pick it up and throw it over the side, and he'd be back at square one again, right? These big stockpiles, because of MSHA, not OSHA, but with the mining it's MSHA, and you have to have a berm in front or around the perimeter of your pile so the loader operator doesn't accidentally drive off the side or somebody doesn't walk off the side. This is a big one too here. Okay, we've done everything right up to this point. We've got our stockpiles separated and marked. That's pretty good. That's a class act right there. How about that? I'm saving room. And you think of the tolerances that you have on your gradations for your mix designs and stuff. That's a nightmare there. So yeah, you save some room at the hot plant, but you created a nightmare for yourself. Proper loadout. If those trucks are staging to where you can only go into one spot in the pile, you're done. You're going to have segregation problems. So you've got to be able to manage your trucks and stage them in the right areas where you can work that whole face. And I know the truck drivers, if you go in there and approach them the right way and say, you know, I've got to be able to work the whole face to get a good load for you. Can you please move over a little bit? They'll move over. But you've got to tell them to do that. Otherwise, they'll be all over that pile. And if they don't, you can deal with it, right? We'll just bury them. They'll move next time, right? That's a little humor, guys. Another way to manage the trucks is to build a little berm around your stockpile so they don't park in areas where you can't manage them properly. We've got to be able to direct the trucks because they can really mess up the operation if you don't. They're trying to do their job as efficiently as they can, and we've got to give them all the help we can to make that happen. And again, Trenton talked about this. You don't load directly out of a cone-shaped pile like this because you know you're going to get segregation. And it can be dramatic to where the guys in the quarry can do everything and through the secondary and tertiary, and it's going into the stockpile, and the loader operator doesn't get it out of the stockpile the right way and get it remixed, because we all know it's going to come apart as it goes through that process. We're done. Moisture is critical, especially in a dense graded material where you've got that big particle distribution size in there. So you've got 200s all the way up to 1.5 inch rock in one size pile. Moisture, if you put moisture with it, it's going to hold it together. It dries out, it comes apart. We're going to do a demonstration on segregation with wrap out of a stockpile that you're going to put in your plant and show that the gradation and the binder content can vary the way you work the stockpile. What I've got here is a 5-gallon bucket with a hole cut in the bottom of it. This is what I'm going to build my stockpile with. And then here we've got a 5-gallon bucket of wrap. That's been processed. Okay, so it's gone through the process, and now it's going into the stockpile. Don't want to waste any. All right, now we've got our stockpile. This is going to represent our loader. And the demonstration is to illustrate if you don't work the entire face of the pile, that you're going to experience segregation in this stockpile. So here we go. First 3 scoops that go into my hopper.
And notice I'm going in the same spot in the stockpile each time. So now, being the brilliant loader operator that I am, I'm going to go back into that stockpile in the same spot and get another 3 scoops. Okay, here is the first material that I put into my hopper. And here is the second 3 scoops that we put in the hopper. And you can see, and you will see on the next set of slides, the difference in the gradation and the binder content, but you can physically see there is a dramatic difference between the first 3 scoops and the second 3 scoops.
Okay, here's what we got. This is the first bin, and this is all percent passing. And this is the second bin, so this is the outside. This is the center cone fines. This is the average of these two put back together again mathematically. And then this over here was the average gradation for the wrap before we put it through the demonstration. So you can see here, let's just start out at the 1/2-inch sieve. First bin 98, the second one was 99.8. Now it starts coming apart, the 3/8, 87.5 to 94.7. The number 4 sieve, 52.8 to 72. 20% difference. Just by my being a brilliant loader operator. 20%. And the next one is, again, about 20%, 36 to 57, 27 to 46, 20 to 34, and then all the way down to your 50 sieve, it's still a 10%, 14 to 24. Your 200s, look at that one, 5.8, 8.7. And then we did a burn on these, and the difference in the AC content, 3.72 to 4.78. Difference in the binder content between those two. And again, it's just segregation. And you can see here, I don't know if you can see because I'm probably standing in the way. When you put the averages back together, you come pretty darn close to what we had to start with. So you just think of what you can create by not working a stockpile properly. And I thought doing it with the wrap was a really good illustration because it not only showed you the difference in the particle size distribution, but because you've got all those particles coated and there's much more surface area in those fine particles, it also really affected your binder content. I've done this demonstration for a lot of years, but usually I use the base materials. It comes apart just like the wrap did. So I did the same exact experiment where I took 3 scoops from the outside and then same spot for the second one. The thing that's interesting with this one is you can see my stockpile sink, third column over there, that I'm in compliance all the way down. No penalties, I'm right in the middle of the spec. But when you look over at the first scoop, I'm out of spec on the 3/8 sieve and the number 10 sieve. And on the second one, I'm out of spec on the number 10 sieve. Way too fine. I went from the material out of the stockpile at 32% to 54% passing. I'm in some pretty heavy penalties now, and it was just because it wasn't worked properly. So you can see, and again, this is a VDOT spec. This isn't their brand new spec, the 2016, but you can see that I've gotten myself into some real trouble here with what I did with that base material, just by not working that stockpile properly. I've cost myself some money or my customer some money. And again, when you look at the stockpile sample, bam, they nailed it. It was right down the middle. So just by not working that pile properly, I've created some issues for me or my customer or both. And the bottom line is, what happens to the service of the road? It's going to come apart too, right? But this was a really good definition of quality. Quality is what the customer says it is, right? Customers are always right. Quality has another characteristic in that it can be physically measured. If all the measurements add up to what the customer defined or needed, then you've provided quality. And as you saw in those last couple slides, the plant operation did everything they could to get that material to make the measurements that our customer VDOT wanted. They did a really good job with it. But just think, just because it was loaded out of that stockpile into the truck the wrong way, we're not in this, we don't meet the definition of quality anymore. And that's just the beginning. When they bring it out to the plant and dump it on the ground and push it, they rack it up into the stockpile and it starts all over again, right? When you guys load it into your coal feed, and then just take it beyond that. So you ran it through your plant and did everything right there. And you kept your silo full when you were loading the trucks. And it went out to the paving crew, and they didn't do their job right. They let the hopper run empty and lifted those wings up on the paver. And so every 20 yards, you've got a segregation in the road. I know you've all seen that out there. I'm sorry, too. So anyway, it goes, think about all the hands that this material goes through, from drilling and blasting to getting density on the road. And every time it goes through one of those handoffs, we have an opportunity for a fumble. Everybody's got to pay attention to what they're doing. So in summary, be consistent in what you do. And that's one thing that affects the operation all the way through also, is being consistent. When you're loading out of that stockpile, you know, even down there at the beginning with the shot, you know, work that. Make sure you're giving them a good consistent feed, because that's where it starts. And just think, we talked about it just a second ago. Everyone needs to perform their task properly. Because think of all the handoffs that take place from the primary crusher all the way down, again, to density out in the field, the laydown. Think of all the handoffs. Again, it's just tremendous. But if everybody does their job the right way and pays attention to what they're doing, and it's no harder to do that, we get a good job at the end. Know your customers' needs and concerns. How important is communication to teamwork? Listening, asking questions. And that's a big, big part of it. Again, you know, we're a big team here, from drilling and blasting all the way to laydown. And if we don't communicate well with each other, if you don't know what you don't know, right? So ask questions. Keep in contact with your customers. Make sure that we are meeting their needs and that their needs are defined well enough for us. Because if we don't know, we can't fix it. So communication. Measure what you're doing. We do that in the plant all the time, right? We're constantly running gradations and doing adjustments, and we do process samples. We do quality control samples, so we check the stockpiles, we adjust our operation, our crushers, to make sure we're putting a consistent product out. And then we also check the material as it's been loaded on the truck to make sure that we don't have segregation issues going on there. And then we actually go out and take samples at our customers' yards and work together with them to make sure that they're not doing something that's creating segregation. Because again, it's a lot of handoffs, so we've got to pay attention to what our customers are doing and what their customers are doing. It keeps on going, right? And this, this last one's one that really hits home too. Know that if we don't meet our customers' needs, our competition will.